So what we're looking at today is 4.2, Elvira's equations. So what we're going to be looking at within here is what's known as literal equations. So literal equations are equations that are either all letters or almost all letters. So that's why we've done so much practice with the solving 1 and 2 step equations where we're just solving for one variable, because now we're going to be looking at these equations that we use for various things. I mean, these are formulas that we use. You could use them in science, you can use them in math. They're all over the place. There's so many formulas that have a bunch of different variables, and sometimes we don't know certain parts, so we have to rearrange the equation so that we can have our solution be what we need it to be instead of something else. So that's what we're going to be looking at today, is practicing with solving these literal equations, which is basically just rearranging them. So that's why we went over how to take and move a number from one side to another, and moving things and keeping an equation equal and isolating the variables and all of that, because that's going to be a major thing today. Is you have to know how to move it, especially when it's not numbers. You can't just go, oh, well, if I plug this in, then I'm going to get this. That's not going to work anymore. So let's go ahead and jump on into this. So maybe, hang on. There we go. Okay, so isolate the variable with inverse operations. So isolate the indicated variable and then fill in the blank for the statement that follows. Solve for x. Ax equals 7. We want to get x by itself. So I can find 1x or x by doing what on both sides of the equation. So how are we going to get rid of the a? How do we move that over? We divide by a. Let me make this bigger. So divide by a. So we're going to divide by a in order to get x by itself. So we'll have x equals 7 over a. So that's our solution for 1. Number 2, we want to solve for p. So we have 8 plus p equals w. I can find 1p or p by doing what on both sides of the equation? So how are we going to get this 8 to the other side? Well, we're going to subtract it. So subtract 8. So if we subtract 8, we're going to have p equals w minus 8, just like so. All right, the next one we're looking at is number 7. So here we want to solve for h. So we have 7 minus h equals 0. I can find h by blank on both sides of the equation. Now, there are 2 different ways to take and do this one. One would be to subtract the 7 and then divide by -1. The other would be to just add the h over, because this is 0. So if we just add h over, then we'll have h equals 7. So we're going to do it that way. It's fewer steps, which I'm sure most of you are thrilled by because you don't like lots of steps. So add h. All right, the next one we're looking at number 8. So we want to solve for y. So we have 1/2 y equals k. So how are we going to get rid of the 1/2? Well, to get rid of a unit fraction, meaning when we have 1 over some number, we multiply by the denominator. So we're going to multiply by 2 to both sides. So we have y equals 2k. So multiply by 2. And then the last one we're going to look at together is number 9. So we want to solve for h. Notice a lot more variables in this one. A equals b times h divided by 2. This is the area of a triangle. This is the formula for that. So in this case, we want to have it solved for h because maybe we know the area and we know the base, but we don't know the height. So this makes it a little easier if we rearrange the formula for solving. So first thing we need to do is take care of this 2. So we need to multiply both sides by 2. So times 2. So I'm going to write it off to the side here. So we have, random lines. So we have 2a equals, BH. So multiply by 2. Then we still need to get H by itself. So how do we get rid of the B? We divide both sides by B. So we have 2A over B equals H. And divide B. So we're dividing by B. So, like I said, in these literal equations, and these are definitely simpler literal equations than what we're going to get into. There will be ones where it's all variables. So more like this one right here, and like number 10, having to solve like that, where we have it all variables. And this really gives you a lot of practice with understanding those operations and how to do the opposite operations. So knowing that if we have addition in the problem, we have to do subtraction. If we have multiplication, we need to do division, so on and so forth. So your keyword for this lesson is literal. Literal, because these are literal equations. All right, the next section, defining and interpreting variables and units of measure. Jackson likes to be organized, so he made the following chart. He has decided to keep track of the miles he runs and the time he spends running. He attends PE class on Monday, Wednesday, and Friday, but he goes to school every day. Fill in the units column of the chart. So we've got the symbol M, which is representing the number of miles ran in PE class on Mondays. What unit is that going to be in? Well, what are we measuring? We're measuring the number of miles, so this is miles. Next one we're looking at is S, the number of miles from Jackson's house to the school. Once again, what are we measuring here? Miles. So it's all about looking to see what are we measuring in here. And the next one we are looking at T sub M, so time in minutes spent running in PE on Monday. So what are we measuring? We're measuring time, and in what unit does it tell us we're measuring it? Minutes. So this is minutes. So you guys will fill in the rest of that chart, okay? All right, so make meaning of the expressions below. Write what they each mean. If an expression does not make sense, say why. And I will tell you there's only one that does not make sense. So don't just write they all don't make sense, because it's all variables. So for 11, M plus W plus F. So what we're looking at is number of miles ran on Mondays, number of miles ran on Wednesdays, number of miles ran on Fridays. So what are we looking at? Number of miles in a week, because he only goes to PE Monday, Wednesday, and Friday. So miles in a week. So, whoops. I don't know why I just did that. Miles in week. All right, the next one we're looking at is 15. So T sub M plus T sub W plus T sub F. So these are all the time spent running in PE Monday, Wednesday, and Friday. And then we're dividing it by 3. So what are we finding? If we're taking and adding them all the times together and dividing by the 3 times that there are, we're finding the average time ran per day. That's what we're finding there. All right, the next one we're looking at 17, M plus H. So M is the number of miles ran in PE on Mondays. H is the time in hours to travel to school. Do those have anything to do with each other? No, so this is the one that does not make sense. The units don't match. Units don't match. Because the units on the H is going to be hours. So even though we didn't have that one, this one is hours. So if our units aren't the same, we can't combine them. So keep that in mind. All right, the next section. So this is set and interval notation. So below you will find the domains of several different functions. The domains are described in either set notation or interval notation. And we want to fill in the missing notation. So here we have x. When x is an element of the real number system, so that's what that stands for. We've been over that before. -2 is less than x is less than 6. So we've got our two values here. We've got the low end and the high end. So for interval notation, we're going to have -2, comma, 6. There's our interval notation. Now, for set notation, we have the interval, -4 to 7. So we start with x when x is an element of the real number system. -4 is less than x is less than 7. Just like that. That's what you're doing for these. Now, 24 looks a little different because it's -infinity to +infinity. So how we do this, that just means it's all real numbers. So we say x when x is an element of the real number system because it's everything. So that is your answer there. That was the hardest one that was on there, I will tell you. All right, for 25, which notation, interval or set, would be most appropriate when working with a domain of whole numbers? So if it's just all whole numbers, then it's going to be easiest to use the set notation because we can just say x when x is an element of the whole numbers. All right. For each of the inequalities provided, graph the values being described on the number line. I don't know why it says numbers. For 26, we have x is less than 6. So we come over to our number line. It's always good to take and mark where 0 is on our number line. So marking a 0. So there's our 0. And then we have 1, 2, 3, 4, 5, and 6. So here is 6. Now, we have just a less than symbol. So that means we are going to have an open circle here at 6. When we have this inequality, so when we have less than or greater than, it's an open circle. When we have less than or equal to or greater than, or that's supposed to be a greater than or equal, hang on, or greater than or equal to, it's a closed circle. So that is crucial to know. Make sure you know this. You have to know this. So now to take and graph this line, so we've got where it's at, the 6, and it's less than 6. And whenever our x is on the left-hand side, we can follow what the inequality says for direction. So the inequality is pointing to the left, which means so is our line. So there is x is less than 6. Now, for 28, we have x is greater than or equal to -9. So here I'm going to put a -10. We've got -9. Oops, hang on, it's all blurred together. Maybe. -9, and then we go all the way down to 0. Now this one, it's a greater than or equal to, so it's got the equal to part, which means it's a closed circle. So we're going to have a closed circle here at -9. And then if we look, it's greater than or equal to, which means it's going to go to the right. So it's going to go off this direction. And yes, my line is very wavy. You guys can draw much nicer lines, but I'm trying to do it here on the computer, so it's a little more difficult. So this is what it should look like approximately. All right, the next one we're doing. So here we have a low end and a high end. So it's saying 3 is less than or equal to x is less than or equal to 25, which means 25 is on the high end, which I don't know why it eliminated my 5 on my 25 there. And 3 is the low end of this because x is in the middle. So they both have the equal to, so that means we're going to have closed circles for each of these. So a closed circle at 3, a closed circle at 25, and x is less than 25, so it's going to go this way, but x is greater than 3, so it's the space in between is where x exists. So be careful with 29 and 31. It'll be the same idea, okay? All right. If you guys have any questions, feel free to ask.